Venkata Rao, Professor of Mechanical Engineering, Department of Mechanical Engineering, IARE, Hyderabad. Now, I will discuss about the topic Traveling Salesman Problem using Dynamic Programming. So, the topics to be covered are Introduction, Dynamic Programming, Examples. Suppose a salesman wants to visit certain number of cities allotted to him. He knows the distance, cost or time between every pair of cities. His problem is to select a route that starts from his home city and passes through each city once and only once and come back to his home city at a minimum cost or at a minimum distance. Then suppose 4 cities are there. When 4 cities are there, then we can get 6 routes. In that 6 routes, we have to find out the cost. So that means we will get 6 solutions. In that 6 solutions, we have to select the best solution. Suppose 4 cities, 1, 2, 3, 4. 4 cities are there. This is the home city. You can go from 1 to 2, 2 to 3, 3 to 4. Or you can go from 1 to 3, 1 to 4, and then 4 to 2, 2 to 1. Like that, you can select different routes. So he has to select the least cost route. So if the number of cities are 4, we can get only 6 paths. If the number of cities are more, then we can get more number of routes. So in that case, it is very much difficult to find out the solution for all the routes, and then we have to select the best one. In that case, the dynamic programming is very much useful to find out the solution. So the problem is 2 types. If the distance or cost or time between every pair of cities does not depend on the direction of the journey, this is called as the symmetrical type problem. If the distance or cost or time changes with direction of journey, then the problem is called as the asymmetrical type. Now, dynamic programming, it depends on principle of optimality. So that means dynamic programming find out all possible solutions and select the best solution. So it takes more time because it has to find out solutions for all the possible solutions. So it will take more time compared to the other method, but still it gives a better solution. For solving complex problems, the problem is breaks down into sub problems and find optimum solutions to each sub problems. And the solutions of these sub problems are stored and reused to find out the optimum solution of a complex problem. This dynamic programming can also be used for the linear programming, traveling salesman problem, knapsack problem, shortest path problems, longest common subsequence, and many other problems it can be used. Now, consider the example. A traveling salesman wants to visit 3 cities, 2, 3, 4, and come back to home city 1. The cost matrix for these cities is given below. Find minimum cost route. So, the data is given. So, based on the data, first we have to construct the Statespace Diagram. So, first we have to consider the one is the starting city, and then from city 1 to the salesman can go from 1 to 2, 1 to 3, or from 1 to 4. So, this is the starting city, and then he can go from 1 to 2, 2 to 3, and 3 to 4. From 2, he can go to 3 or 4. So, from 3, he can go to 4, and then he come back to 1. So, from 4, he can go to 3, and then he can come back to 1. So 2, 4, 3 and 1. So this is the one possible way. The another way is he can go from 3 to 2, 3 to 4. Then he can go from 2 to 4 and then he can go to 4 to 1. Next, from 4 to 2 he can go, so 3 to 4, 3 to 2, 2 to 4, 4 to 1, and then he can go 4 to 2 and then he can come to 1. So similarly from here he can go from 4 to 2, 2 to 3, 3 to 1. So from here he can go 4 to 3, 3 to 2 and 2 to 1. So these are the different routes available for the salesman. So he has to select the shortest route for his plan. So now this is the state space tree. Now we can find out the distances from here. From 4 to 1, so the 4 to 1, the distance is 5. 4 to 1, the distance is 5. 3 to 1, 3 to 1, 3 to 1 is 4. And then 4 to 1, 4 to 1 is 5. 4 to 1 is 5. Then 4 to 1 is 5. Then 2 to 1, 2 to 1 is 8. 2 to 1 is 8. Then 3 to 1 is 4. 3 to 1 is 4. Then 2 to 1 is 8. So the salesman can go from 4 to 1, the distance is 5, or cost we can say 5. From 3 to 1 it is 4. 2 to, then 4 to 1 is 5, 2 to 1 is 8, 3 to 1 is 4, and 2 to 1 is 8. After this, the salesman can go from, suppose if the salesman starts from 3 and going 4 and then come back to 1. In that case, again we can find out the distance. So what is the distance from 3 to 4? 3 to 4 is 9. So that this distance is 5 plus 9 is 14. So 5 plus 9. 3 to 4 is 9. So the distance is 14. Then suppose the salesman goes from 4 to 3 and then 1. In that case, the distance 4 to 3 is 2. That means here the distance is 6. 4 to 3 is 2. That distance is 6. This is coming from 3 to 4, 4 to 1, 4 to 3, 3 to 1. Now suppose the salesman goes from 2 to 3 and then 3 to 4 and then 4 to 1. In that case, what is the distance here? 2 to 3. 2 to 3 is 13. 13 plus 14 is 27. Suppose if the salesman goes from 2 to 4, 4 to 3, 3 to 1. In that case, what is the distance? 2 to 4. 2 to 4 is 16 and 16 plus 6 is 22. So, in this two routes are available. One is 27, another is 22. So that he can select the shortest route, that is 22 from here. Suppose if the salesman goes from 3 to 2, 2 to 4 and 4 to 1. In that case, what is the distance? Now, 2 to 4, what is the distance from 2 to 4? 2 to 4 is 16. 16 means the distance here, 16 plus 5 is 21. Then, if the salesman goes from 3 to 2, 2 to 4, 4 to 1. In that case, what is this distance? 3 to 2. 3 to 2 is 7, so that it is 28. So, the distance here is 28. Next, suppose if the salesman goes from 3 to 4, 4 to 2 and 4 to 1. In that case, what is the distance? Suppose 4 to 2, what is the distance from 4 to 2 is 12. So, 12 plus 8 is 20. Suppose it is 20. Suppose from 3 to 4, what is the distance? 3 to 4 is 9. That means this distance is 29. So the salesman can select the shortest path from here 3 to 2, 3 to 4, 4 to 1. Now consider the another one. Suppose if the salesman goes from 4 to 2, 2 to 3 and 3 to 1. In that case, what is the distance from 2 to 3 or cost from 2 to 3? 2 to 3 is 13. So this is 17 and then 4 to 2. 4 to 2 is how much? 4 to 2 is 12. That is 29. 4 to 2. 4 to 2 is 12. That is 19. Next. Suppose if the salesman selects the another path, that is 4 to 3, 3 to 2, 3 to 1. Then 3 to 2 is how much? 3 to 2 is 7. So that it is 15. And then 4 to 3. 4 to 3 is how much? 4 to 3 is 2. If the salesman goes from 1 to 2, 2 to 3, 3 to 4, 4 to 1, in that case the cost is 27. Suppose if the salesman goes from 1 to 2, 2 to 4, 3 to 4 to 3 and 3 to 1. So in this the shortest path is this one. So the cost corresponding to this is 22. Next, if the salesman goes from city 1 to 3 and 2, 3 to 2, 2 to 4, 4 to 1. So the cost is 28. If we select the route 3 to 4, 4 to 2, 4 to 1, the cost is 29. So in these two, we have to select the lowest one, that is 28. Then next one is the salesman can go from 1 to 4, 4 to 2, 2 to 3, 3 to 1. In that case, the cost is 29. And then if the salesman selects the route 1 to 4, 4 to 3, 3 to 2 and 2 to 1. In that case, we have to find out the cost. Here, 22 is the minimum and 1 to 2. What is the cost corresponding to 1 to 2? 1 to 2 is 16. 16 plus 22 means 38. 38. So, if he selects the route 1 to 3, in that case, what is the cost? 1 to 3. 1 to 3 is 11. So, the distance is 39. 38, 39. And then, if the salesman selects the route 1 to 4, 4 to 3, 2 to 1. In that case, what is the cost? 1 to 4. 1 to 4 is 6. So, the cost is 23. So, that means the lowest cost. Now, the three costs are there. 2, 23, 38, 39. So, in these three, he can select this one. So, the corresponding route is this. 1 to 4, 4 to 3, 3 to 2, 2 to 1. So, this state space diagram is useful to derive the formula for the dynamic programming. So, from the formula, we can find out the solution for any number of cities. That is, we can derive the general formula. Now, now we can write the formula for this. So, the cost of going from city 1 to set of cities 2, 3, 4, 2, 3, 4 is equal to, we can write the formula. So, going from city 1 to set of cities 2, 3, 4 is equal to minimum of, you can write C, we can write minimum of C 1, 2, that means going from the cost of the edge from 1 to 2 plus cost of going from city 2 to the remaining set of cities 3 to 4, 3 to 4, comma, then C going from city 1 to 3, city 1 to 3 plus the cost of the edge 1 to 3 plus cost of going from city 3 to 3 comma set of remaining 2 comma 4 remaining cities 2 comma 4 comma C of going from 1 to 4 plus, so this is the cost of an edge going from 1 to 4 plus cost of going from city 4 to the remaining cities, that is 2 comma 3, this one. So in these three we have to select the minimum. So either first one or second one, that is going from 1 to 2 or going from 1 to 3 or going from 1 to 4. So by using these costs we can finalize the route. So this is the cost of going from city, starting city 1 to the remaining cities 2 comma 3 comma 4. So in this we have to find out these values again. So for that we can write the formula, the cost of going from city 2 to set of cities 3 comma 4. So that is equal to, you can write this one is equal to C of minimum of C of 2 to 3 plus, that is the cost of an edge 2 to 3 plus cost of going from edge 3 to the remaining set of edges, that is 4 comma C of 2 comma 4 plus G of 4 comma remaining set of edges. So this one. In these two we have to select the minimum one, either this one or this one. So like that we have to write for this one also, G of, that is the cost of going from starting city 3, the remaining set of cities 2 comma 4. So 2 comma 4 is equal to a minimum of C of 3 comma 2 plus G of 2, that is cost of going from city 2 to the remaining set of cities 2 comma 4 comma C of going 3 comma 4, that is the cost of edge from 3 to 4 plus G of 4 comma set of 3. So like this you can write for this also similarly, then we can find out the values and then we can find out the total cost. Now the same thing has done here, you can see. So from this you can write the general formula, G of I comma S, that is the cost of starting vertex I to the set of vertices is equal to minimum of C of starting vertex I to another vertex K plus cost of the vertex K to the set of vertices minus K. So K belongs to set of vertices, I is the starting vertex, S is the set of vertices. So by using this is the general formula. So here the stage 3 is clearly explained. First 4 to 1 is calculated and then 3 to 4 1 distance cost is calculated and then 2 3 4 1 cost. The 2 3 4 1 cost is 27. 2 4 31 cost is 22. I already explained the same thing is represented here. Then when the salesman goes from 1 to 3, 3 to 2, 2 to 4, 4 to 1, the corresponding cost is 28, and 1 to 3, 3 to 4, 4 to 2, 4 to 1, the cost is 29. So again, when the salesman goes from 1 to 4, then the cost is 1 to 4, 4 to 2, 3, 4, 2 to 3, 3 to 1, then the cost is 29. Then when the salesman goes from 1 to 4, 4 to 3, 3 to 2, 2 to 1, the cost is 17. So now again we have to find out the cost corresponding to 1 to 2. So when the salesman goes from 1 to 2, the corresponding cost is 22. 1 to 2, 2 to 3, 3 to 4, 1 is 27, and 1 to 2, 2 to 4, 4 to 3, 3 to 1. That cost is 22. In this we have to select the minimum 22, and the corresponding cost from the edge 1 to 2 is 16, 22 plus 16 is 38. So the next one is 1 to 3. 1 to 3 in the minimum cost is 28, and 1 to 3 is 11, 28 plus 11 is 39. Then the third option is going from 1 to 4, and then again two routes, 4 to 2, 2 to 3, 3 to 1. So here 4 to 3, 3 to 2, 1. So here two costs are there. One is 29, another one is 17. In this 17 is the lowest. So we can find out the cost corresponding to this. The cost corresponding to this is 23. So there are three costs are there. One is 23, 38, 39. So we have to select the three solutions. In that we can select the best solution. The best solution is 23. That means the corresponding route is 1 to 4, 4 to 3, 3 to 2, 2 to 1. The same thing is highlighted here. Now you see 1 to 4, 4 to 3, 3 to 2, 2 to 1. So like that we can find out the paths. Now we have to derive the formula. For deriving the formula, we can use this Statespace diagram. So the cost of going from city 1 to the set of cities, that is 2, 3, 4, is equal to minimum of cost of 1 to 2 plus that is cost of 1 to 2 means the cost corresponding to the edge 1 to 2 plus cost of going from city 2 to the remaining set of cities 3, 4. This one are going from 1 to 3. Going from 1 to 3. That means the cost of an edge 1 to 3 plus cost of going from 3 to the remaining set of vertices 2, 4. C of, that means cost of going from 1 to 4. That is cost of an edge 1 to 4 plus cost of going from 4 to the remaining vertices 3, 2. So for calculating this we need these values. So I analyzed here the cost of going from 2, 3, 4 here. So that is minimum of cost of going from 2 to 3 plus cost of going from 3 to set of vertices 4. So the value we have to find out. So first of all we need this thing going from 2 to 1, that is coming back, going from 2 to 1. So what is the cost corresponding to 2 to 1? 2 to 1 that is reaching the home city, returning the home city, that is 2 to 1 is 8. 2 to 1 is 8. Then 3 to 1 is 4 and 4 to 1 is 5. So from the table we can find out the values of cost of going from 2 to 1, cost of going from 3 to 1, cost of going from 4 to 1 are known. After that we have to calculate the cost of going from city 2 to the remaining set of vertices, that is 3. So this can be calculated like this. Cost of an edge 2, 3 plus cost of going from 3 to 1. 3 to 1 is coming back to the home city. So C of 2 to 3. Now you can see C of 2 to 3. Cost of going from city 2 to city 3 is 13. So this is 13 plus 3 to 5. 3 to 5 is, that is 3 to 1. We can say 4. The total cost is 17. Similarly, cost of going from 3 to 2 also we can calculate. Cost of going 3, comma, the remaining set of vertices 2 is equal to cost of going from city 3 to 2, that is cost of energy 3 comma 2 plus cost of going from 2 to 1. So that is equal to 3 to 2, 3 to 2 is 7, 3 to 2 is 7 and 2 to 1 is 8. So 7 plus 8 is 15. So first we calculated 2 to 3 and 3 to 2. Similarly, we have to calculate 2 to 4 because these are required for calculating G comma 4, G of 4 comma 2 3 or G of 1 comma 2 3 4. These values are required. Next, coming to the cost of going from 2 to starting vertex 2 to the remaining set of vertices 4 is equal to cost of energy 2 to 4 plus cost of going from 4 to 1, that is equal to C of 2 to 4. C of 2 to 4 is 16 and G of 4 to 5 is equal to 5. 16 plus 5 is 21. So G of 2 comma set of 4 is equal to 21. Again we have to find out G starting vertex 4 to the remaining set of vertices 2, so that you can know the value. So that is equal to C of 4 comma 2 cost of going from the city 4 to city 2 plus cost of cost from 2 to 1. So that is 12 plus 8 is equal to 20. That means C of 4 to 2 is 12 here and 2 of 5 is equal to 8, that is equal to 20. Similarly, cost of going from the starting vertex 3 to the set of vertices 4 is equal to cost of energy 3 comma 4 plus cost of going from 4 to 1, that is equal to C of 3 to 4 is C of 3 to 4 is 9 plus 4 comma G of 4 comma 5 is equal to 5. So this value is 14. So G of 3 comma set of 4 is equal to 14 and again G of 4 comma set of 3 is equal to C of 4 to 3 plus G of 3 to 5. G of 3 to 5. So that is equal to C of 4 to 3 is equal to 2 and 3 to 5 is equal to 4. This value is equal to 6. Now, so after calculating these values, now we have to calculate G cost of going from the starting vertex 2 to the remaining set of vertices, that is remaining cities 3 comma 4 is equal to minimum of cost of going from 2 to 3, that is cost of energy 2 to 3 plus cost of going from the city 3 to the remaining set of vertices, that is 4. That is equal to C comma 2 to 3, 2 to 3 is 13, 13 plus this G 3 comma 4 we are already calculated, that is 14. So 13 plus 14 is 27. Next, C of cost of going from 2 to 4. So cost of going 2 to 4, that is cost of energy 2 to 4 plus cost of going from 4 to the remaining set of vertices, that is 3, is equal to 16. So 16, what is 16? 2 to 4. 2 to 4 is 16 and G of 4 to 3 we are already calculated, that is equal to 6. That is 6. So 16 plus 6 is equal to 22. Now G cost of going from the starting city 3 to the set of remaining cities 2 comma 4 is equal to minimum of cost of going from 3 to 2, from city 3 to 2 plus cost of going from city 2 to the remaining set of vertices 4 is equal to this C of 3 to is 7, 7 plus, we are already calculated g of 2 comma 4 is equal to 21, so that this value is 28. Now, cost of going from city 3 to 4 plus cost of going from city 4 to the remaining set of vertices is equal to 9. So, C3 to 4 is 9 plus this g of 4 comma set of 2 is equal to 20. We are already calculated. So, this cost is 29. Now, we can find out g of 4, that is cost of going from the city 4 to the remaining set of cities 2 comma 3 is equal to a minimum of c comma cost of an edge 4 to 2 plus cost of going from 2 to the remaining set of vertices is equal to this c 4 comma 2 is equal to 12, g 2 comma 3 is equal to 17. So this cost is 29. Now we have to find out cost of going from 4 to 3, that is starting vertex 4 to the next vertex 3. This is cost of an edge 4 to 3 plus cost of going from 3 to the remaining set of vertices is equal to 2 plus 15 is 15, because 4 comma 3 is equal to 2 and g of 3 comma 2 set of vertices 2 is equal to 15. So the cost is 17. Now we have to substitute these values in the final form. So cost of going from city 1 to the remaining set of cities is remaining set of cities 2 comma 3 comma 4 is equal to minimum of cost of an edge 1 to 2 plus cost of going from city to the remaining set of vertices 3 comma 4 comma cost of going from 1 to 3, that is cost of an edge 1 to 3 plus cost of going from city 3 to remaining set of cities 2 comma 4 comma cost of going from cost of an edge 1 to 4, that means cost of going from 1 to 4 plus cost of going from city 4 to the remaining set of vertices 2 comma 3. In this 3 we have to select the minimum one. So in the first case, c of 1 to 2, c of 1 to 2 is 16 and g of 2 comma 3 set of 3 4 2 comma 3 4 is equal to 22. So 16 plus 22 is 38. So 38. Next, c cost of going from 1 to 3 plus g of 3 comma set of 2 to 4 is equal to 1 to 3. 1 to 3 is 11 and this value is 28. So that this is 39. Then coming to the last one, cost of going from 1 to 4, that is cost of an edge 1 to 4 plus cost of going from city 4 to the remaining set of cities 2 comma 3 is equal to this is 1 to 4. 1 to 4 is 6 plus this is 17. So the cost is 23. So this cost 23 is corresponding to going from 1 to 4. This is 1 to 4. G of 4 comma 2 3. This G of 4 comma 2 3, in this the minimum is this. That means 4 to 3, 3 to 2. And then we can write 2 to 1. So this 3 to 2. So 3 to 2 is from here. So that is 15. So that we can, this is the path. 1 to 4. 1 to 4. 4 to 3. 2 to 1 is the route, and the cost, minimum cost is 23. So in this way we can find out the path by using the dynamic programming. So simply we have to use the formula for finding out the any number of cities. The general formula is, the formula for dynamic programming is cost of going from starting city to the set of vertices is equal to minimum of cost of going from city I to k plus cost of going from city k to remaining set of cities. K belongs to S, and I is the starting vertex, S is the set of vertices. So in this way we can find out the solution. This is general formula. By using this general formula we can write the algorithm and then we can find out the solution. Now consider the another example. A traveling salesman wants to visit 3 cities Q, R, S and come back to home city P. The cost matrix for these cities is given below. Find minimum cost route. Now, so first we can draw the state space diagram. So first we can start from P, then we can go P to Q and then Q to P to R, and then we can go from P to S. So the salesman can go from P to Q, P to R, or P to S. Then Q, he can go Q to R and R to S and S to P. This is the one path. Or he can go from Q to S, S to R, R to P. This is the another path. Suppose if he goes from P to R, then we can write R to Q, R to Q, Q to S, S to P, R, R to S, S to Q, S to Q, and then Q to P. This is the another path. Then he can go from S to Q, Q to R, and then R to P. So here S to R, R to Q, and then Q to P. So this is the state space diagram. This is useful to generate the formula or to develop the general formula for finding out the solution in dynamic programming. So now we can find out the distances here. So from S to P, what is the cost corresponding to S to P? S to P is 8. Then R to P, R to P is 6. R to P is 6. Then S to P, S to P is 8. S to P is 8. S to P is 8. And then Q to P is 5. Then R to P, R to P is 6. And then Q to P, Q to P is 5. So we have to coming from the reverse direction. S to P, R to P. Then we have to find out the cost when the salesman goes from R to S, S to P. So what is the cost corresponding to R to S? R to S is 12. So this cost becomes 20. So 12 plus 8 is 20. Next, coming to the S to R. What is the cost corresponding to S to R? S to R is 9. So that this is S to R, R to P is 9 plus 6 is 15. So we can find out this distance. Next, coming here, Q to S. Q to S is how much? 10. So that this distance is 18. This distance is 18. Then S to Q. S to Q is 8. So that this distance is 13. So 5 plus 8 is 13. Then Q to R. The distance Q to R is 9. So that this is 15. This is 15. Then R to Q. R to Q is 13. So that this distance is 18. So like that we can find out the distances. Now again we have to find out when the salesman goes from Q to R, R to S, S to P, and then Q to S, S to R and R to P. In this we have to select the lowest one, lowest cost route we have to select. So now what is Q to R? Q to R is 9. So that means you are getting this is 29. And then Q to S. Q to S is how much? 10. So that this is 25. This is 25. Next, coming to the R to Q. R to Q is 13. So that 13 means this cost is 31. Then R to S. S is 12. So that this is 25. This cost is also 25. Next, coming to S to Q. S to Q is 8. That means this is 23. Then S to R. S to R is 9. This is 27. So we found the costs corresponding to going from Q to P and R to P and S to P. So here two paths are there. In that we have to select the minimum values, that is 25 here and 25 here and 23 here. So next, suppose if the salesman goes from P to Q, Q to R, R to S, S to P, or P to Q, Q to S, S to R, R to P. In that case, what is the cost? What is the cost corresponding to P to Q? P to Q is 35. P to Q is 35. Then P to R. P to R is 15. 15 plus 31 is 46. Is 46. Then, in this we have to take the minimum. So minimum is 25 again here. So P to R is how much? 15. 15 plus 25 is 40. 15 plus 25 is 40. Then P to S. P to S is how much? P to S is 20. So in this minimum is 23. So this is 43. So three costs are there. One is 35, another one is 40, and the next one is 43. So in this we can select the lowest one. So that is 35. 35. That is corresponding to which route? So this is 43, this is 40, this is 35. So this is coming from 25. So in this the route is this. So the route is P to Q, Q to S, S to R, R to P. So this is the shortest path because the total cost required to going from city P to city Q and then S and then R and then coming back to the original city. Now the same thing is explained here. Now the same thing is explained here. You see. So this route cost is S to P is 8, R to S to P is 20, Q to R, R to S, S to P is 25. This is 29. Then Q to S, S to R, R to P is 25. So in this 25 is the minimum. Next, going from P to R, R to Q, Q to S, S to P is 31, and then P to R, R to S, S to Q, Q to P is 25. So in this also the minimum is 25. So here also 25. Next, going from P to S, S to Q, Q to R is 23, and going from P to S, S to R, R to Q, Q to P is 27. So now we have to select the minimum cost. So after calculating the distances, suppose if the salesman goes from P to Q, Q to S, S to R, R to P, the cost is 25 and P to Q is 10, so that this cost is 35. Suppose if the salesman goes from P to R, R to S, S to Q, Q to P is 25 and P to R is 15. So 25 plus 15 is 40. So that corresponding to this, here we selected the minimum cost. Again here, suppose if the salesman goes from P to S, S to Q, Q to R, R to P, the cost is 23. But P to S is 20, the total cost is 43. So three costs corresponding to the three routes. So in this we have to select the lowest one. The lowest cost is 35. So the route is this one. So that is highlighted here. Now you see the route P to Q, Q to S, S to R, R to P. So like that we can find out the route. So based on the state space diagram, we can write the formula for the dynamic programming. So by using that formula, we can find out the solution. Without using this state space diagram, we can find out the solution. But this state space diagram is useful to develop the equation. Once the equation is developed, then we can find out the solution. So the formula for dynamic programming. So already, let us say the cost of going from city P to the set of cities Q, R, S is equal to minimum of cost of energy PQ plus cost of going from city Q to remaining cities set of cities R, S, cost of going from starting city P to R, that is cost of energy PR, plus cost of going from city R to a set of cities Q, S, cost of going from city P to a set of cities, cost of going from city P to S plus cost of going city S to remaining cities Q, R. So this is the formula we have drawn, we have written from the state space diagram. Now you can find out the values. So the cost of going from Q to pi, that is Q to P, is equal to 5. Cost of going from R to P is equal to 6. S to P is equal to 8. So these are the costs we have taken from the table. Then cost of going from city Q to the rest of the cities, that is the set of cities R, is equal to cost of energy going from city Q to R plus cost of going from city R to the rest of cities, that means coming back to the initial city P, that is equal to 9 plus 6. Q to R is 9. The G of R plus 5 is equal to 6. So that this value is 15. Then cost of going from city R to set of cities Q is equal to cost of energy R, Q plus cost of going from Q to the initial city Q, initial city P, is equal to this cost of an edge R, Q is 13. 13 plus Q, pi is equal to 5. So this is 18. Next, cost of going from Q to set of vertices S is equal to cost of an edge Q, S plus cost of going from S to P is equal to 10 plus 8. Q to S is equal to 10 and G S, pi is equal to 8. So that this is 18. Next, cost of going from S to rest of the cities Q is equal to, that is set of cities Q is equal to cost of energy. S to Q is 8. S to Q is 8 plus cost of going from Q to pi is 5. So this is 13. Next, similarly, cost of going from R to the set S is equal to cost of energy R, S is 12 plus G plus cost of going from S to pi is equal to 12 plus 8, that is 20. Next, cost of going from S to the set of vertices R is equal to cost of energy S to R is equal to 9 plus cost of going from R to pi is 6. So that you can find this value is 15. So after calculating this, you can find out cost of going from city Q to set of cities R comma S is equal to minimum of cost of energy Q comma R plus cost of going from R to cost of going from R to a set of vertices S is equal to 9 plus 20 is 29, comma cost of going from city I cost of going from city Q to S plus cost of going from S to set of cities R is equal to 10 plus 15 is equal to 25. So in this we have to take the minimum value. Next, cost of going from R to set of cities Q comma S is equal to minimum of C cost of energy RQ plus cost of going from Q to set of vertices S is equal to 13 plus 18 is 31, comma cost of going from city R to S plus cost of going from S to the set of vertices Q is equal to 12 plus 13 is 25. Next, cost of going from S to the set of cities Q comma R is equal to minimum of cost of energy S comma Q plus cost of going from Q to remaining set of vertices R is equal to 8 plus 15 is 23, comma C of cost of energy S comma R plus G into R comma set of Q is equal to 27. So in this we have to select the minimum 23. Now final formula is this: cost of going from the starting city P to the remaining cities Q comma R comma S is equal to minimum of, there are three parts. One is cost of energy PQ, another one is cost of energy PR, another one is cost of energy PS. So this is cost of PQ plus cost of going from city Q to the remaining cities, set of remaining cities R comma S. So this value we have to find out. Similarly, cost of going from cost of energy P comma R plus cost of going from city R to remaining cities Q comma S, comma cost of going cost of energy P comma S plus cost of going from S comma Q comma R. So we have to find out these values. In the first case, the cost is 10 plus 25. That means C of PQ is 10 and cost of going from Q to R to S is 25. So this is 35. In the second case, the cost is P to R is equal to 15 and this is equal to 25. So the cost is 40. And the third case, 20 plus 23 is 45. 20 plus 23 is 43. In the minimum values is equal to 35. So 35, 40, 43. In this minimum we selected so that the route is. So this is the path. Path is equal to Q to R, P to Q, Q to S, S to R, R to P. That is the route. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.